Hello and welcome. Come to the presentation of some new products from ETI range. Today we will talk about the correct procedure in the selection of overcurrent protection of solar inverters with AC voltage 800 volts. So there is few procedures, few products regarding proper protection of AC side of solar inverters. This is the example of string inverter from one very famous producer, and there is a lot of technical information connected with this product. You can see technical data and types, input side, output side, everything. There is written rated AC grid voltage 800 volts. Of course, today we are speaking about this range. But there is written for output protection, there is written maximum external AC overcurrent protection is 200 amps. It's not written which kind of protection, which characteristic. Everything depends about installers and proper procedure how to make decision about protection of on AC side. So protection is not defined. This is example of PV installation with string inverters and combiner boxes. Proper protection must be selected on AC side of the inverter, definitely. On the market exist a lot of procedures, but today we will see some examples how to solve this problem. From the customers, and we are receiving a lot of information about use of so-called semiconductor fuses for the protection of outputs of inverters protection. There is competitor's product technical characteristic. You can see that it is designed for 800 volt AC and breaking capacity 65 kiloamps, and characteristic is GR. This fuse is very good, but we need to know that application where such fuse is installed should be very carefully calculated. As I said, power dissipation 25 watts and breaking capacity 65 kiloamps. There is also information about pre-arcing integral and total integral of the fuse. Comparable ETI product designed for 800 volts AC, also with rated current 200 amps, but with a characteristic GG. We can see that power dissipation is much lower, 16 watts, and breaking capacity is 120 kiloamp. Pre-arcing and total integrals are also different comparing with this competitor product which we saw on previous slide. Let's see what is the difference between different characteristics, GG, GS, and so on and so on. Let's take fuse with nominal current 100 amps, which is loaded with 5 times nominal current, so with 500 amps. We can see that breaking range of GS or GG is between 2 or 4 seconds. Breaking time of GR characteristic is 150 milliseconds. So GR is 30 times faster than GS or GG in this maintained range of overcurrent, 5 times. Similar characteristic is if the same fuse is loaded with 10 times nominal current, so with 1000 amps. Breaking time of GG is 200 milliseconds and breaking time of GS is 15 milliseconds. So in this range, 10 times nominal current, GS is much faster than GG. It's 13 times faster than GG. In standard IEC 269-4 are defined complete technical requirements for fuse links with GR and GS time current characteristic. It is the name of this standard is supplementary requirement for fuse links for the protection of semiconductor devices. So there is difference in non-fusing current. GR has 1.1 nominal current and GS has 1.25 nominal current. It is important in real application if fuse link is selected properly. There is a usual diagram of solar inverters which need to be protected. Output of solar inverters need to be protected with fuses, and also complete line should be protected with fuses, but selection of those fuses is important. Installation cables between points 1 and point 2 should be protected with GG. Fuse links with GG characteristic. It is important. Inverter AC short circuit protection and connection cables between between output of inverter and point 1 should be protected with GS fuse links. Fuse links with GR or AR time current characteristic are not suitable for the protection of DC-AC inverters installation on 800 volt side, because GR is too fast for cable protection, has much higher power dissipation, and too low breaking capacity. So, as we saw on our previous slide, GS fuse links should protect cable and power semiconductors on AC side, and GG are designed for protection of connection cables. TTI has quite a big range of NH fuses for 800 volt AC. So size 00, size 1 up to 160 amps, size 3 up to 315 amps. It was regarding GG. Regarding GS characteristic, we have again size 00 GS up to 125 amps, size 1 up to 315 amps, size 2 GS up to 400 amps, and size 3 GS up to 500 amps. Regarding requests from the market, we are ready to develop some new type or new rated currents and so on. We are very open regarding this request. Regarding fuse bases, we can offer usual PK 00, PK 1, 2, and 3 usual fuse bases, or horizontal fuse switch disconnectors type KVL, and fuse switch disconnectors different types. Some pictures: GG range up to size 3, and GS range also up to size 3. That would be all for now. In case of any additional questions, please contact me, and I will stop sharing this presentation, and thank you very much, and goodbye.